Hello everyone. So in this question you have to draw the output waveform for the given circuit and the input applied is impulse. Okay, so this is the first question and this is the second question. Okay, so first let us analyze this circuit. So here you can see that we have applied an infinite amount of voltage at t equals to 0. See, if you know the property of an impulse signal, you would know this is not the magnitude. Vs is not the magnitude. Vs is the area. Okay, so the amount of voltage applied at t equals to 0 is infinite only. So if there is infinite current, infinite amount of voltage applied at t equals to 0, then the current flowing through the RC circuit at t equals to 0 will be infinite only, because at t equals to 0, what would be the current? The current at t equals to 0 will be Vs into delta t by R, because at t equals to 0 there is no charge on capacitor, so it would be 0 only, here 0 only. So the current will be Vs by R into delta t only. Okay, so I have already explained this one. If there is an infinite amount of current flowing through a capacitor, then the capacitor will change its voltage all of a sudden. See, what does the property say? The property says that the capacitor can't change the value of its voltage instantaneously. But if there is infinite amount of current, this property doesn't follow. At infinite amount of current, the capacitor will change its value instantaneously. So at t equals to 0, what you see? What is the value of capacitor voltage? 1 by C integration I dot dt. So we are integrating it from 0 minus to 0 plus only. We are seeing it at t equals to 0 only. At t equals to 0. So we are integrating from 0 minus to 0 plus. And from 0 minus to 0 plus, what is the value of current? Vs delta t by R. Zero minus to 0 plus into dt. So what do you get? Vc at 0. Vc at 0. Vs by Rc. So this is the voltage at t equals to 0. So at t equals to 0, we are having Vs by Rc voltage. Now at t equals to 0 plus, this input is gone. At t equals to 0 plus, this input is gone. Okay, so the circuit will be something like this: R shorted and capacitor C till Vs by Rc into V naught. So now with time it will discharge, and at infinity it will completely discharge, and the value of the capacitor voltage will go down to 0. So what will be the expression of V naught? V naught t. At t equals to 0, it is Vs by Rc, and it will go down to e to the power t minus tau. Here tau is Rc only. So from at t equals to 0, Vs by Rc, to at t equals to infinite, it will go down to 0. So this is the output expression. So the waveform would be this will be the waveform. Okay, so now some of you may have a doubt that at t equals to 0, how is voltage Vs by Rc? Okay, like I mean the value, what is the unit of Rc? Rc is second, and many of you think this is volt only. So it is volt by second, and this is not the unit of voltage. So this must be wrong. No, I have already told you that this Vs is not the magnitude. This Vs is area from the property of impulse signal. So Vs is already volt into second. It is already volt into second only, and now we have divided it by Rc. So divided it with second, so it is volt only. So this Vs by Rc shows the unit of volt only. Okay, so let me explain it once again. See what we saw here. We saw that at t equals to 0, there is infinite amount of current in the RC circuit. So because of infinite amount of current, there will be an instant change in the voltage of capacitor. So we have found that the instant change was from 0 to Vs by Rc. Okay, Now what we see, now what we saw that at t equals to 0 plus the input is gone, so whatever amount of voltage the capacitor is having, it will completely discharge through the resistor. So this is discharging. So that's how the waveform looks like. Okay, otherwise you can find it by Laplace transform only, not Laplace transform as well, but in the interview you can't do that. They expect you to go like this. Okay, so moving on to the second question. Okay, so in this one you again see at what is happening at t equals to 0. At t equals to 0 we have again applied an infinite amount of voltage. Now again at t equals to 0 this should be short circuited, and the what will be the current at t equals to 0? Again the current at t equals to 0 will be Vs into delta t by R. So this amount of large current is flowing through the resistor, and that the same current is flowing through the capacitor only. So again a large amount of current is flowing through the capacitor. Now again the capacitor will develop an instant change in voltage. So at t equals to 0, what is Vc? Vc at t equals to 0, Vs by Rc only, by the previous derivation, this derivation, Vs by Rc only. Okay, so at t equals to 0 we are having capacitor voltage at as Vs by Rc. And now what will be the value of V naught at t equals to 0? The input voltage minus capacitor voltage. So the input voltage at t equals to 0 is Vs minus Vs by Rc. Now is it right? Is it right? No. At t equals to 0 the voltage is not Vs. At t equals to 0 voltage is Vs delta t. So now it is right. Okay, so let me write it again. Vs delta t minus Vs by Rc at t equals to 0. And now at t equals to 0 plus, at t equals to 0 plus, again this input is gone, so the circuit will be V naught. Now it is charged to, see the direction. Okay, now it is charged to Vs by Rc. Okay, now with time it will completely discharge in this direction. Yes, in this direction it will completely discharge in this direction, and V naught will go out to 0. So Vs delta t. Okay, so this is at t equals to 0. Now if you want to write the expression at V naught with respect to time, so you will write Vs delta t minus Vs by Rc. Now it will completely discharge, so e to the power minus t upon Rc ut. Okay, see all of this is happening at t greater than 0. That's why I have applied ut. Okay, now you solve it further. So what you get, Vs delta t into e to the power minus t upon Rc into ut minus Vs by Rc e to the power minus t upon Rc into ut. Now you see this complete expression can be reduced to Vs into delta t only. You see at t, so this will be this will be there at t equals to 0 only. So put t equals to 0 in this one, so it will be 1, and in this one it will be 1 only. So it will be reduced to Vs delta t by simple properties of impulse signal. Okay, minus Vs Rc into e to the power minus t upon c into ut. Or you can simply see, you know the equation of voltage across this capacitor. You already know it. Vs by Rc e to the power minus t upon Rc. Okay, now you have to write the value of V naught t. So what will be the value of V naught t? It will be Vi minus Vs by Rc. There should be ut as well. In the previous expression I forgot to apply the ut, so it should be ut. Okay, so Vi minus Vs by Rc e to the power minus t upon Rc into ut. So it will simply be Vs delta t minus Vs by Rc e to the power minus t upon Rc into ut. Okay, like this. Okay, so it was an easy problem. So let me explain it once again. So first we saw that there was an infinite amount of current. So because of the infinite amount of current, there was an instant change in the value of capacitor voltage. So because of that, we got the expression V naught T, something like this. Or we can simply write it by the previous expression. We know the what will be the waveform of capacitor voltage. So this was the capacitor voltage, and what is V naught T here? V naught T is simply Vi minus Vs by Rc e to the power minus T upon tau into ut. So we can write it like this. So for the waveform, okay, so this will be the waveform. And now there is one more way to write the expressions. Okay, so first we will go for this one. So you know what is the impulse response across the capacitor in this circuit? What is step response? Okay, no, not impulse response, step response. What is step response? So V naught T is step response. V naught T is Vs into 1 minus e to the power minus t upon Rc into ut. So now for getting the impulse response, what you need to do? You simply need to differentiate it. So dv naught by dt will be your impulse response only. Impulse response. So now how will I differentiate it? Vs. Now differentiation this. Now differentiating this, I will get e to the power minus t upon Rc into ut. Now is this differentiation right? No, this is wrong. The differentiation is wrong. Luckily you got the right answer, but the differentiation is wrong. You can't differentiate any function like this. See, there is ut as well, so you can't differentiate it like this and simply apply ut in the after differentiating. So that's not the correct way of differentiating. Okay, so how you will differentiate it? First write v naught t as Vs into ut minus e to the power minus t upon Rc into ut. Now differentiating it will be Vs. Differentiation of ut is delta t. Now apply u into v formula here. So it will be Rc into delta t. Now the e to the power minus t upon Rc, and because of differentiation we will get minus sign and ut. Okay, so it will be delta t at t equals to 0, it will be 1. So delta t minus delta t will be 0. So Vs into e to the power minus t upon Rc ut. So this is the answer. So you can do it like this as well. You can apply the same in this as well. Okay, so what is the step response? Step response is Vs into e to the power minus t upon tau ut. Now simply differentiate it. Impulse response will be Vs into e to the power minus t upon tau del t plus, not plus, because of the differentiation we will get minus here, to the power minus t upon tau into ut. So what are you getting here? Vs at t equals to 0, it will be 1. Vs into delta t minus Vs e to the power minus t upon tau Rc u of t. See, it is the same only. Okay, so I have told you many ways, but in the interviewer will expect this analysis from you, not this one. Okay, you may tell him like after the step response I can calculate the impulse response like this as well, but he will expect this analysis from you, that you need to tell him what is the amount of current, why the capacitor is having an instant change in its voltage, and all these stuffs. Okay, thank you.